Okay, so good afternoon. No? So once again, this is 4-101, combination of ComSci, IT, IS, and I think data science students. No, all are freshmen, with a few sophomores. Okay, so last meeting we discussed. I gave you an introduction to the course, and we discussed the first topic, which is history of computing. You follow? So I'd like you to look at our regular class. No? So I already have uploaded the meetings there. No, do you follow? So apat, and then I've also uploaded the meeting earlier this morning. No, okay. So last meeting we introduced the history of computing, and uh, we also mentioned the significance of history in the development of computing technology, right? We are studying history particularly because we want to know how things or how technology evolved. Okay, we are not just trying to memorize or mention a series of events like we do in common history. We are going to show the structure of the different computers, no, and how they came to be in their current state. Okay, so remember, no, the first computing machines after the abacus was invented in 1642 to 1644 in France. No, they could do addition and subtraction by Blaise Pascal. And then in Germany, later in 1673, Gottfried von Leibniz invented the step reckoner, which can do repeated multiplication by repeated addition. Now, this is a mechanical device which uses binary system, no? Because Leibniz was a strong advocate of the binary system. Okay, and then on the area of recording, no, Joseph Marie Jacquard invented the Jacquard's loom, which can be used to read and write data into wooden tiles. No, a loom is a weaving machine, no, a machine you use to weave fabric. Instead of using fabric design, it uses representation. It represents quantities, no, in decimal. And then in 1820, no, early 19th century, Thomas de Colmar, also from France, invented the arithmeter, which was the first commercially known mechanical calculator, no, which does 4 operations. Okay, so the modern period started in the early and mid 19th century. No, Charles Babbage invented the first computer. No, his first invention, the differential engine, was not considered a computer. No, his second invention in 1837 was introduced. No, it's called the analytical engine, the first mechanical general purpose computer. He is now known as the father of the contemporary computers. No, okay, we will study the analytical engine today. At the same time, no, since his product was not recognized by the scientific community by that time, no, only one other mathematician, okay, recognized the significance of his work and proved that his invention can be used to solve mathematical problems. Okay, do you follow? She was Augusta Ada King, no, Countess of Lovelace in Great Britain. Okay, she was first recognized. She is recognized today as the very first computer programmer. During those days, she published algorithms. No? During those times, they are called algorithms. No? Intended to be carried out by the analytical engine. Nowadays, we call them programs. Okay. Later, also in that same century, in the US this time, okay, Herman Hollerith invented the punch card tabulating machine, which replaced the Jacquard loom. Do you follow? It was actually patterned after the Jacquard loom. Instead, this time, it no longer uses fabric weaving machines, no, but it uses a mechanical punch card machine. Do you follow? No, IBM punch cards. So here's an IBM punch card. No, this was used in 1880s. No, because the U.S. performed one of their earliest census or population count. No, and sometimes recording could be very tedious, so they used punch cards instead of papers and pens, no, to record. So each column represents a number, no, you follow, depending on the holes punched. certain quantity is being represented. Okay. Now, Herman Hollerith later founded a tech giant. It's called IBM, no? Which is still popular nowadays. No? That tech giant invented the first IBM PC, which is now the ancestor of what we are, or rather the descendant of what we are using. No? A common computer that we are using. Any questions? Now, the most important question is, what did Charles Babbage invent? How does it look like? How does the computer look like? So, there are two main parts, no? The mill and the store. Okay. So, there are two main components. Okay. The mill and the store. The store is a memory. It's capable of holding 1,000 numbers, decimal numbers, no? Of 40 digits each. 40 digits. So that's a very large number, right? Kasi kung 9 digits, millions na eh. Diba? So it can hold 1,000 numbers of 40 decimal digits. And then the mill, which is capable of performing arithmetic operations, plus comparisons, and optional square roots. It can also do shifting and evaluation of conditions. No? It can evaluate conditions. No? Let's look at the mill. So ito yung analytical engine. No? And then let's look at the Jacquard loop. Is there a better image of the Jacquard loop? Ito, this is a better image. Okay, ito na lang. Okay, we follow. Can you see that? These are the two main components of the analytical engine. This is the mill and this is the store. Do you follow? There's no image that shows how they are connected. Okay? So the store can contain 1,000 cards, no? Each card can store a particular number. No? Okay, do you follow? So put together, this composes the analytical engine. Okay, this and that. No? Now this is a smaller version of the analytical engine because this can only store 20 digits. No, this was a version that was attempted to be constructed by Charles Babbage himself. Okay, so the mill and the store. Okay, the mill is like the CPU, the store is like the hard disk. Okay, but the store is composed of a Jacquard loom. Kasi these are the only available things during those times. Do you follow? Any questions? That's the invention. And now, how does it work? Do you follow? How does it work? Let's show that. No. So we have here the two slides: programming the analytical engine and the programming cards. Okay. So this is how it is. No. So if you look at the analytical engine, the mill looks like this. No. It has 1, 2, 3, 4. Actually, 1, 2, 3, 4, 5. 5, no? Actually, itong dalawa, this is the egress 1, ingress axis. This an axis is a string of gears, okay? 20 gears, no? Each gear is labeled 0 to 9. Ito, this is 40, I think. 40, no? So this is the first ingress axis. I think this is the first ingress axis, no? Ito yata, no? Ito. The second ingress axis, and we have the egress axis. And then we have the prime egress axis. Do you follow? What do we mean by ingress? Ingress stands for input. Egress stands for output. Do you follow? So ingress means input variables. Egress means result. Do you follow? Because in a formula, you will have an input variable and an output variable. Okay. Now, Charles Babbage attempted to use a prime ingress axis because he wants, during division, he wants to make use of a large 20 large numerator during division, and such that he will be able to divide a 100-digit number by a 50-digit number. So dito yung 100-digit, this is the divisor is a 50-digit number, and the egress axis can store the quotient, and the remainder can be in the prime egress axis. Do you follow? No? How does it work? It still doesn't answer, no? Now, it works on 3 different kinds of cards, no? Okay. Operation cards, okay, number cards, and variable cards. Do you follow? Operation cards can store the operations plus, minus, times, divide. Okay. Number cards are used to assign values, so assignment statements. And variable cards are used to transfer data from the mill to the store or store to the mill. Okay. So operation cards require only 4 holes to represent: plus, times, plus, minus, divide, times. Okay. Number cards require 50 columns, no, of 10 possible punches. 50 columns of all 10 possible punches, because each column can have 10 possible punches from 0 to 9. Okay. And number cards contain 50 columns. Operation cards can only contain 4 holes, no. So naka-indicate if it's in the first hole, it's a plus. If it's in the second hole, it's a minus. Third hole, divide, and so on and so forth. In the variable card, no, one of the 5 possible punches, there are 5 possible punches which can contain. Dito sa there are only 4. Dito there are 50 columns, no. The variable cards indicate transfer from the store to the mill or the mill to the store. Okay, do you follow? So for example, L001 is used to load the value 001 into the mill. S002, particularly the egress, to either ingress or egress axis. Okay, do you follow? S002 transfers the egress axis into the store. Okay, do you follow? We will demonstrate this by an example, no? CF is count forward 5 times depending on the result of the last operation. Now, the analytical engine, particularly the mill, has a run-up lever. What's a run-up lever? It's like a toggle switch. No? The run-up lever will be set to true if the last operation results to a negative value. Okay? It will be 0 if the last operation is 0 or positive. Okay? So there's a better, there's another, the programming cards. Okay? So for example, if you have N001, can I enlarge this? N001, this is an assignment statement. N0010 means the variable N001 is assigned a value of 0. Do you follow? And then N275, the variable 275 is assigned a value of 10,000. N302 is assigned a value of negative 1,321. Do you follow? Or like this, N10, which means the second rather store is assigned a value of 0. Any questions? So, ang N, remember, can have 50 columns. A number card can have 50 columns. Each column is 10 rows. Okay, do you follow? Because depending on the number that is being stored. Okay. So operation cards can have four rows. Okay, and the variable cards. When you say L001, okay, after an operation, usually, the L is the sequence is like this. There's an operation, L00 followed by a load, followed by another load. What does this mean? During a math operation, the first load is the first parameter, the second load is the second parameter. Do you follow? And right away, upon completion of the second load, the operation is executed and the result is stored in the egress axis. Okay, I have there a sample program which is used to compute the fourth factorial. Let's try to load that. No? Okay. Okay. So there are two versions, no, of the fourth factorial, without loop and with loop. Okay, you know what a loop is? It's a part of a program which is repeated depending on a condition. There are two types of conditions in a loop: condition for continuation or condition for termination. For the loop continues if the condition for continuation is satisfied. If it's not, the loop stops. Okay. If a condition for termination is evaluated and it's true, the loop halts. Otherwise, it repeats. No, baligtad lang sila. This is the fourth factorial. Do you follow? What is a fourth factorial? Can anybody tell me what a factorial is? Anyone? What's a fourth factorial? What is the first factorial? What is the first factorial? Anyone? Walang marunong ng factorial? Any volunteer? What's the first factorial? Okay. The first factorial is 1. Why is that? Because it's 1 times 1 equals 1. What's the second factorial? Anyone?
2, sir.
2 po.
2. Why is that?
2 times 1.
2 times 1. Good. What's the third factorial?
6 po.
6. What's the fourth factorial?
24.
12. That's 12, 24. Yeah, that's correct. I'm sorry. No? 24 because it's 12 times 2. Okay. So that's a factorial program. No? There's also another version which is the summation program. Okay. So let's study this. No? When you say N004, now this is our, let's look at the program before we proceed, written by Ada Lovelace. No? Kita natin dito, no? The Tale of Ada Lovelace. Nandito, no. Wala dito yung program niya. Meron pero ito maliit. Okay? This is the program written. Nandito na. Let's have a bigger version. I think it's in Ada Lovelace and the in this in the source, no? And the analytical engine. Ito yung program niya. Do you follow? Can we enlarge this? This is the program written by Ada Lovelace. Here are the operations and then the variables used. Ang ginagamit is IV2 and IV3. Actually, V means variable. Okay, this is IV2, IV3, IV1, IV2, IV3. These are variables, and these are the resulting variables. Then she has an explanation. Okay, and then she has an explanation of what is being done, and then he will show the results here. Do you follow? So she's doing this manually, no? So it's a very cryptic representation. Nowadays we will use our worksheet. Ito, ganito. This is the same thing as Ada Lovelace worksheet. Do you follow? We have here the operations, we have here the mill, and we have here the store. Okay. The store is labeled variables 0, 1, 2, 3, 4 until 999 because there are 999 of these. You follow? Okay, this is the program for the fourth factorial as written in that source, no, from Stanford University. No? Do you follow? So this is the mill and the store put side by side, although not visually, no, but logically the same. Okay? Do you follow? No? Ito yung the store, ito yung the mill. When you say N004, you are setting the variable 0 to 4. N is an assignment statement. So this brings the value 4 to this. You follow? Any questions?
Good afternoon, sir.
Yes.
I'm sorry, sir. I'm late. I went to the wrong class.
What's your family name?
Crystal Imudin, sir. I went to the wrong class.
Okay, next you log in with your full name, no? Put your
Yes.
family names first.
Okay, sir. Thank you.
Okay.
Excuse me, sir.
Oh,
Me too, sir. I went in the wrong class. Remolio Jacob.
can you chat me? Remulio Jacob. Is there another class? The first one? Siguro sa programming, no? Kasi there's an intro to programming also. Okay. Okay. Anyone else? You just chat me, no? Anyway, I'm seeing your chat, no? Okay. So anyway, let's go back. When you say N004, this is an assignment statement. Variable 0 is assigned a value 4. Okay, so we are using this variable as our next multiplier because in the fourth factorial we multiply, no? And then the constant decrement N001 1. So this is the position 1. This will be our decrement each time we pass through the loop. Okay, the first one we take 4 minus 1, then 3 minus 1, then 2 minus 1 until we reach 1 minus 1. Okay, and this is our partial product, which is initially 1. Do you follow? You can download this worksheet now, by the way, no, in our Dagler site. Okay, nandito sa ating Dagler site. Ito, no? The fourth factorial program. Okay, do you follow? You download this worksheet. I just erased the content so we can trace it from scratch. The next card is a times. This is a variable card. The first 3 cards are numeric cards, no? Times. Okay, so which means that the next operation will be a multiply. L002, which means that 002 will be loaded to the mill. Particularly, it will be loaded to ingress axis 1. Sorry na. Why? Because it's the first load. Okay, during the first load, the store goes to the ingress axis 1. Okay, L00, the second load, this goes to ingress axis 2, which is 4. And right away, after the loading of the second operand or parameter, the operation is performed. So 4 times 1 is equal to 4. So it's stored to the egress axis. Do you follow? Do you get my point? Kenji Barrios. Okay. Do you get my point, everyone? Okay. So the first load goes to ingress axis 1. The second load goes to ingress axis 2. And right away, the computation is done and the result is in egress axis 4. Do you follow? So this is a modern version of the worksheet by Ada Lovelace, no? Complicated yung kanyang worksheet, okay? They can afford that anyway because they are smart people. Genius, no? Babbage and Ada Lovelace. And when you say S002, the result of the egress axis, this one goes to the position 002. So this becomes 4 now. Do you follow? Okay. Any questions? So ngayon, I will let you do the computation itself. When you say minus, no, the next operation is a minus. L00 at 0. What happens to ingress access 1? Anyone? What value will be stored in ingress access 1? Can you chat me, anyone?
1, sir.
Ingress access 000. Ito kukunin natin dito sa 0. What's the last value of 000? 4. Do you follow? 4 kasi ito nga. L000. So itong si 000 papunta sa ingress axis 1. Do you follow? Okay. Now, L001, what will happen to ingress axis 1?
1, sir.
1. 1. Kasi 1 na yung na doon, di ba? And then right away 4 minus 1, right? Pagkatapos mo, this will be 4 minus 1. What happens to egress axis? This becomes
3 po.
3. Very good, no? Ganun lang naman, okay? We are already writing a very simple program, no? So, and then we say S000. What happens to 000? The egress axis will be transferred to 0. What will happen to this? This will become as ano? Yung
3,
sun-
sir.
Do you follow? Kasi matransfer nga yung egress axis sa 0. This is the next multiplier. The first multiplier is 4. The next multiplier is 3. Then we have a times. Right? What is 002? L002. So ito. Right? Ingress axis 1. What value is stored here?
1, sir.
No. What's the value of the B002?
4, sir.
4 ito. Galing sa dito. No? It's from here. And then L000. What's the value of this?
3 po, sir.
3, sir.
3. That's good. No? 3. Why? Because it's from here. No? So what will be done right away? 4 times 3. This becomes 12. Diba? Questions? Right away, upon the loading of the second parameter, the operation is executed. S002, what will happen to this? What value will be stored here?
12, sir.
12.
12, sir.
That's the next partial product, okay? And then we go to the minus L000. What happens to egress axis 1? This becomes
3.
3.
3.
L001, what's the last value? It's fixed. This becomes 1. Okay. 3 minus 1, this becomes 2. Okay. S000, this becomes 2. Do you follow? And then we multiply L002. What's this? 12. Right? 12. Okay. L000, this is 2. Right away, this becomes 24.
24.
Good. 24. And S002, this becomes 24. Okay. 24. And then finally, we will have a minus of L000, which is 2, and 001, which is 1. 2 minus 1 is 1. Okay. And then this will become 1. 1 is the last multiplier. We do not end without a 1. Okay. So times L002 is 24. L00 is 1. This becomes 24. And S00 becomes 002 becomes 24. And we're done. Do you follow? P means print. It will print the value 24 to the last available card. Okay. B means bell. A bell will ring to awaken the sleeping attendant. Okay. And H is halt. Kasi ganito yon, no? If you look at what's being done, no? What's done in the analytical engine. Okay, ganito daw ang ginagawa. Let me look at for that, no? Ito. Before the program is run, the program is written on a series of punch cards, right? Okay. The program is written by an analyst. Okay. Analyst ito. The analyst then was actually the programmer. Do you follow? The program written by the analyst is prepared on a chain of cards, and it is then submitted to the engine's human attendant. The human attendant examines it for possible errors and requests for actions by the attendant. So kung may makita, if the attendant finds something wrong, he will ask the analyst to correct it, and it's difficult to correct, no? Because he has to rewrite everything from scratch. Okay. For example, to include cards for previously prepared standard computation and so on and so forth. After completing all requests, the attendant now prepares the chain and determines that it's real. Then mounts the chain on the card reader. Ilalagay na niya doon sa card reader, okay? And causes the engine to process it, and initiates the engine to process it. Okay? Meron pang isa si estimada. Mamaya na lang, no? Okay. So, mag-fire na yung engine. Okay? Pag-load ng card, mag-fire na yung engine one by one. Okay? Interpreting the one by one. And then the attendant just leaves it going. Sometimes he goes to sleep. Why? Because it's a very long process. So that's why, no? We have P, B, H. P means print, B means bell to awaken the sleeping attendant, and H means halt. Do you follow? Do you get my point?
Yes, sir.
Now, if you are going to run this on your computer, it will take you time. You need some coffee. It will put you to sleep. Okay? This is a very boring process. No? The writing process is interesting, but the running process is very boring. Okay? Any questions? Now, let's write the one with a loop version. Now, take note that in the documentation of the analytical engine, there's a run-up lever. Nandito, no? Sa isa, no? Okay. Here. Okay, there's a run-up lever. Okay. CF means count forward, no? Or move forward. When you say count forward 5, you forward by 5, depending on the run-up lever. CB, count backwards 5, depending on the run-up lever. What is a run-up lever? A run-up lever is like a toggle switch, no? Yung toggle switch, like this, which automatically toggles. It's like this, no? A toggle switch, when it's set up, it's on. When it's set down, it's false. On or off, no? Do you follow? Depending on the last operation, the run-up lever will either be set to 1 or set to 0. If the last operation is negative, it is set to 1. If it's a non-negative or 0 or positive, it's set to 0. Do you follow? So this is the mechanism for writing the repetition structure for the analytical engine. Okay. Now there's a loop version so that we can run a program regardless of what the factorial number is. Although this is a 4th factorial, we can use this to, write the 5th factorial, the 6th factorial by just changing the first line. Okay. When you say N004, this is the 4th factorial. When you say N005, that's the 5th factorial. Okay. Let's erase this first. You can download this worksheet ready now. Fully filled up from our regular site. Okay. Do you follow? Now we will introduce the run-up lever here. Initially, it's set to 0. So if there's no operation card, it remains at 0. Okay. Are you ready? Okay, let's run this. Repetition ito, no? So N004, so this becomes 4. N0011, this becomes 1. This is our partial product. This is our next multiplier. N0021, this is our decrement, standard decrement. Any questions? So N is an assignment statement, no? Assign variables. Okay. And then the first operation is a times. L001. What happens to egress access 1? Anyone? To make a long story short, this is 1. Why? Because 001 here is 1. L000. This is 000. This is 4. You follow? What happens to the egress axis? Anyone? What's the value
4,
here?
sir.
4. Very good.
4.
Yes. What's the run-up lever? 0. Sorry. 0. You know? Any questions? Why it's a 0?
Okay,
Why is it
positive
zero?
siya, sir.
Because the last value is positive. Diba? Is 4 positive or negative?
Positive.
Positive. So pag positive, 0. Do you follow?
If negative, sir.
1. Okay? Pag negative, 1. Binary siya in this aspect. Okay? S001. What is S001? This becomes 4. Do you follow? No? Because the egress axis will now be stored to S001, which becomes 4. The next is a minus, right? What happens to this? What's the value here?
Or,
Anyone?
sir.
Or,
4.
sir.
What value is this? 02?
1, sir.
1, because that's a decrement. So 4 minus 1?
3, sir.
3. What's the egress axis? A run-up lever?
0, gab.
0.
Sir.
0, no? And S000, okay, this now becomes 3. It's our next multiplier, okay? So ito yung dapat tatandaan. And then we'll go to a minus again. Okay, we go to a minus. Can you still see the worksheet now? I hope it's clear. Is it clear on your side?
Yes, sir.
Yes, sir.
Minus L002. What is L002? 4. 4 siya, oh. Aling dito, 4. Ah, no, sorry, 1
One.
pala, 1. 1. L000.
3.
3.
3. Bakit 3, no? Yan. 3. 3. 1 minus 3.
2.
Negative 2. Diba? Run up lever.
1.
1.
1.
1. Okay. So, ito ang tanong ngayon. The next is CB question mark 11. Ibig sabihin, count backwards 11 times if the run up lever is 1. Right? If the run up lever is 1, it will go back 11 commands. If the run up lever is 0, it will go to a PBH, which means it's done. Is it done at this point? No. Why? Because the run up lever is 1. So what will happen when you say CB question mark 11? We'll have to count backwards 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So dyan magsimula. Now, by the way, if you look at the medyo nahirapan ako dito sa original in the original class kasi that actual I took it from here, no? This is a sample program. Okay? Where's the sample, May kulang na minus in the sample pro. If you run this, may kulang na minus dito. Oh. Do you follow? Dapat before S0 and L2, there should be a minus here, no? Okay? That's why we have this minus here. Kasi dito walang minus in the actual code. Okay? It was a mistake, no? So, babalik tayo dito sa times. Okay? But before we do that, let's record the last values. Okay? So that we'll not have a hard time scrolling, no? This is 3. What is our first partial product? This is 4. Oh, sorry, this is 4. This is 1. Do you follow? No? Okay. So, we repeat, right? It's clear why we repeat because the run-up lever is 1. Okay. Now, the next is times L001. What is this? This becomes, to make a note, 4. And this L00. This becomes 3. So 3 ang L00, okay, sinulat natin. 4 times 3 is 12. It's positive, so the run-up lever is 0. Do you follow? 0 ang run-up lever because it's 12. And we say S001. Okay. Okay. S001, so this now becomes 12. Do you follow? The last value, which is the egress axis, is stored to variable 1. Okay, are we clear? Then we'll have a minus. Minus of L00. What's L00? 3. 3, no? 3, di ba? 3 pa. 3 pa siya, di ba? L002.
1.
1.
1 ito. That's always 1. So 3 minus 1? 2. Right? The run-up lever is 0. When we say S00, so the next multiplier is 2. Do you follow? Any questions so far? No? So, it's a process of computing the next multiplier and computing the next partial product. Di ba? The first minus, the first times computes the partial product. The next minus computes the next multiplier. And the next minus evaluates if we are going to continue or not. Okay? Do you follow? Okay. So we have a minus L002. What is 002? This is 1.
1, sir.
Sorry. Mali tayo dito. Dito ang 1, no? L002. What's L000?
2.
2.
2. Sandali lang ha. Di ba tayo nagkamali? 1 minus 2 is negative 1 na eh. Negative 1, saan ba? Tama. Negative pa eh, no? So 1 minus 2 is negative 2. The run-up lever is 1. Right? Do you follow? CB11. Where will we go? Will we go to the PBH or will we go back to the top? Will we move backwards or forward?
Backwards.
Backwards. So, but how many step backwards?
11.
11. 1, 2, 3, 4, 5, 6, 11. Okay? So, balik tayo dito sa ano. Our last values are 2, 12, 1. Okay? Do you follow? Now, we're in the third pass. So, times L001. So, first
12 po.
compute the first. 12. Then L000. 2. Right? So, this is 24. Right? So, the run-up lever is 0. Then S001. So, this now becomes 24. Do you follow? Do you follow? And then we minus. We compute for the next multiplier. L000. L000 is 2. L002 is 1. 2 minus 1 is 1. Run-up lever is 0. And then we have S000. This is our next multiplier, 1. No? Take note, descending ating multiplier, no? From 3 to 1. Okay? So this 1. Okay? And then, okay, what will we do? We'll proceed to minus. Okay. Minus L002. What's L002?
1.
1. L000?
1.
1. So 1 minus 1 is 0. The run-up lever is 0. Do you follow? Good. Okay. What will we do? The run-up lever is 0. What will we do? Move forward or move backward?
Move forward.
Move forward. What will we do?
Forward.
We print, we ring the bell, and we hold. Our final answer is 24.
24.
Do you follow? No? Do you get the looping process? Now, the CB is used to denote a condition for continuation. Okay? If the condition is satisfied, we continue with the loop. Otherwise, we halt. Okay? Any questions so far? Yung isang class, hindi ko pa nabigyan ng assignment. I will give you your assignment next meeting. Kaya na ba natin? Yeah, next meeting, I'll give you the assignment. Okay? Anong oras tayo ngayon? 7:10 ba?
Ano po? 6:40.
6:40. Okay. I'll give you your assignment next meeting na lang. Mas maganda kung next meeting kasi you'll have the weekend, no? So there's a meters to feet, no? And the Fahrenheit to Celsius. And I'll give you your programming. Ito, I'll give you this na lang, no? And then I'll schedule the deadline to be, when is that? Monday. Monday, no? Kasi kung Monday, kawawa naman yung ibang klase. You will have 5 days. They will have 4 days. O, so it's okay na lang, no? So you write a program to sum the first 4 numbers without a loop. Do you follow? And gave a trace using Excel worksheet. Celsius to write a program to convert Celsius to Fahrenheit. Okay. And then write a program to compute the average of the first 3 numbers without loop. Okay. And write a program to compute the average of the first 3 numbers with loop. Okay. So una average, computation of the sum and the average are the same. Right, diba? Sir, yung 1 to 2 po is 2 po. What, can you explain that to me? Mark or Sal, what are you asking for? Are you
Hello, sir. Yung sa loop po, sir,
Yes.
yung kanina po, yung sa 1 minus 2 equals to negative 2. Tapo.
Negative 1, sorry, negative 1.
Ayun.
Okay.
Thank you po.
But still thank you, no? But still the run-up lever is 1, okay? Do you follow? 1 pa rin, so mag-continue pa rin, di ba?
Yes po.
Okay. Unlike here, you'll have 1 minus 1, 0. Di na siya mag-continue. Okay? So thank you, no? Okay? Pwede na ito sa Monday siguro, no? Can you do this? Let me edit this. We'll answer it anyway, no? Grade computation program pala, no? We have another example. I'll just show you this. I may. And then this. Okay. Kailan ba yung ano? When's the deadline for this? Monday? August 1 at 8. At 8 ba tayo? Okay. August 1 at 8 a.m. Yeah. Okay. Kasi may 7:40 class ako sa August 1. Tayo no, may ano August. So let's just make this 7. Okay. 7 a.m. Okay. You can study in advance the examples on okay. The fourth factorial, the meters to feet, the Fahrenheit to Celsius. Okay. And then okay. And then you submit this. Do you follow? No? You submit this on Monday. We'll discuss this next meeting, okay? How to compute meters of feet, Fahrenheit, okay? Grade computation, no? I-hide ko muna ito. Let me study this first, no? Kasi baka i-hide ko muna itong grade computation, okay? I'll study this first before showing to you, no? Any questions? You download the worksheet and trace it yourself, okay? Okay. So for the moment, it should be enough for now, no? Okay. And then we will discuss the solutions, no? Baka may mali pa nga, baka may mali pa itong iba, no? Any questions? So if you will ask me, no? There are other computers which we will program, no? Virtually, no? Simulation, no? So we will also do the factorial for the IAS computer, the next, no? And then sum and average with loop for the IAS, and then factorial program on the PDP-1, okay? Jump instructions on the PDP-1. This is important, no? IBM PC, because there's a CF and a CB, no? Okay. You will have a programming assignment for the PDP-1. Okay. And then, so yun yung mga 3 computers, no? I hope we can program an early 701, no? They follow IBM 701, an early IBM computer. Okay. And then we will have our formative assessment, okay, right after we studied all of history. Do you follow? Maybe 3 weeks from now. Okay. Okay. Now, you will have problem solving like this, no? In programming, and then I will give you a practice test anyway, no? Okay. So you will, before the actual test, you will have a practice test. Any questions? Any questions?
Sir,
Yes.
yung Excel na nasa screen mo ngayon, sir, where is it located on Diagler po?
Nandito sa fourth factorial for the analytical engine. This, no? Ito. You
Yes,
see
sir.
it?
Thank you po. Yes, sir.
Then there are other examples, no, simpler examples. Meters to feet and Fahrenheit to Celsius. Okay? Can you study this yourself? Madali lang naman ito, no? Okay? Or we just discuss it today. May time pa naman tayo. Ha?
Same lang sila sa anong sir katong i-discuss
I-discuss na
nimo
lang
karon.
natin. I-discuss na lang natin. So, i-erase natin. Meters to feet. How do you compute meters to feet? Multiply it by 3.128. Do you follow? Okay. Multiply it by 3.128. For example, we would like to convert 4 meters to feet. Okay. N004. This is variable, no? ST or store, no? 01, 02, 03, 04, 05. Okay. So N004, this is the input value. And our multiplier is N.38. And then N002 is 1. Okay. We will store our result here. So we have L004, this becomes RAS00, this becomes 4. L001, this becomes 3.28. Okay, so we multiply that. That's the result. Times. Okay, 13.12. And then we store it to 2. This becomes. Ang nangyari? Sorry na. Let me just close this now. I made a mistake. So 3.12. And then we PBH. Do you follow? Do you follow? That's just meters to feet. How do we compute Fahrenheit to Celsius? What's the formula? Subtract 32 from degrees Fahrenheit. The result, you multiply with 5/9. Do you follow? Okay. So, for example, 132 Fahrenheit. Okay. We N00, nandito yung Fahrenheit, 132. 32 is our subtrahend, no? And then multiplier by 5 and divisor by 9. Okay, so first we say we deduct L00, 32. Okay, so 132 minus 32, that's 100. And then we times. Ito yun, 100, no? We store it here. And then we multiply it. So L100 with 5, with this L002. This is L002. Okay, and then 100 times 5, this becomes 500. And we store it to 001, which is 500 here. And then we do a divide. Divide L001, which this is L001, 500, by L003, which is this. We have 5.5, and we store it as the final result. And then we have a PBH. Do you follow? No? Any questions so far? So you can also download it here from our Diagler site. Ang grade computation, guide ko muna, no? I'm going to look at it first, baka may mali na. So you can get it here now. The first 3 programs. Okay. Any questions so far? No? So now here's the exercise which you are supposed to pass on Monday. Now, what's the difference between factorial and sum? Anyone? Can you use the factorial program to compute the sum of the first n numbers? Yes. The difference is instead of doing a times, you do a plus. Diba? What's the factorial of 4? 4 times 3 times 2 times 1. What's the sum of the first 4 numbers? 4 plus 3 plus 2 plus 1. What's the sum of the first 3 numbers? 3 plus 2 plus 1. Diba? Okay. And the other question is, if you know how to compute the sum, can you compute the average? If you know how to compute the sum of the first 4 numbers, can you compute the average of the first 4 numbers? Of course, you can use the same program, right? After computing the sum, you just divide it by the original number. So you 4 plus 3 plus 2 plus 1 divided by 4. Diba? 3 plus 2 plus 1 divided by 3. So that's what your assignment is. You compute the sum of the first 4 numbers without loop. Okay? And then you convert Celsius to Fahrenheit, baligtad. And then write a program to compute the average. It's like computing the sum, but without loop. And then write a second version of the same program, this time using a loop. Okay, so yeah, that's your assignment. You figure it out. The logic is simple, no? Okay. Any questions so far? Due on Monday in worksheet? Yes, this is you use the templates. Ito. You use this as your template. Okay? Ito yung the mill, ito yung the store. You just remove the commands and the values. So Vincent Larisma asking, is there a template? Yes. You use the template here, no? Ito, Fahrenheit to Celsius. Di gawin mo itong Celsius to Fahrenheit. Okay? And then yung factorial program, you can convert it into average. Do you follow? Do you follow? Okay. Okay. Okay, that's good if you follow, no? So use the template there, no? You can download it from our Daigler site. So if you have no other questions, we will end the session, okay? I'll upload the recorded session to our Daigler class. Have you reviewed our previous session? I hope you did, no? Find time to review.
Yes, sir.
Yes.
Sir. Present po, Belen, sir. Nagpasok ko kanina mga 5:30, sir.
Okay, sino ito?
Belen po, sir.
Belen. Belen Brandon. Okay. Anyone else?
Estimada, sir.
Estimada. Estimada, you're marked ano? How about Dominguito? Oribias? Is Dominguito here? Ofamin, Christian? The assignment is already open, okay? So, Ivanica Rose is asking whether it's open. It's already open, okay?
Sir, ang nakalagay po ay Friday pa ma-open.
Friday pa ba?
Opo.
Okay. Open ko na pala ngayon.
Sir, present po ako, sir.
Sino ito?
Ibali po.
Ibali. So, i-open ko na pala na Friday pala ang opening, but Friday ang deadline. Bukas ko na lang i-open, no? Para sabay kayo dun sa other class. Okay? Para sabay 26. August 26, is it okay? Bakit ganon, no? July 1 ang nilagay ko, 29 ang nilagay ko dito. Sorry na. July 21, oh. Are you sure about that? July 29 pang ano? What date is today? 25 pala, no? Sorry. July 26. What date is Monday? August 1, okay? So July 26, starting tomorrow, because the other classes will also have to start by tomorrow, okay? Any questions? The assignment will be open tomorrow. Anyone else? Let me just Atian, Denise, Christian Blanco, Hans Dominguito. Okay. Mary Dawn Makalisang. Mary Dawn. She was here last time. Kenji Israel Mende. Kenji. Carl Justin Natividad.
Present po.
Christian Derek Ofamin. Christian. Okay, no one else. So thanks for coming, everyone. No? See you on Wednesday. I'll upload the recording anyway. No? Bye, everyone. Okay.
Sir.
Thank you, sir. Good
Sir,
luck,
thank
sir.
you.
Sir.
Bye-bye.
Bye.